Welcome students. So today we will learn mixed design as per Indian Standard Method IS 10262. First of all, we consider some design stipulations. Step 1, that is design stipulations. We have M25, cement, OPC, moderate exposure, zone 3, sand and slump is 80 mm, right? So these are all design. First is cement is M25 grade we considered, then cement considered is OPC, that is ordinary Portland cement, then exposure given is moderate exposure, zone 3 sand, and slump given is 80 mm and 20 mm MSA. Okay, maximum size of aggregate 20 mm, rounded aggregate. So in step number 1, we consider Fm is equal to FCK plus 1.65 sigma. Sigma is equal to 4, right? So in our case we have how much FCK? 25 plus 1.65 into sigma is 4. In our case we have 4 because it's M25. Now target mean strength is equal to 31.6 MPa. So our FM is 32. We say this one is 32. So we consider this one is 32 MPa. Now from experience, okay, from table number 5, IS 456-2000, moderate minimum cement requirement is 300. Water cement ratio 0.5 for grade M25, right? So we have considered water cement is 0.5 and minimum cement content 300. Now we switch to step 2. Step 2, water cement is 0.45 from experience. If we check in table 5, we get this, and if you consider by experience, we take 0.45. And now we switch to step 3. Estimate water content from table 2 of IS 10262. See, we are following IS 10262 even in DOE method because we are designing these cubes in India or Indian environment. So we follow, it's better to follow Indian standard codes, right? And MSC 20 we have, right? And W, water, kilogram per meter cube, that is 186 kilogram per meter cube. So now tables are for angular coarse aggregate, slump 25 to 50 mm condition. For each delta S is equal to plus 50. Delta W 3%. Right, so W is equal to 186 into bracket 1.03 minus 25 is equal to 167. In cement we got is 372 kilogram per meter cube, right? If admixture is used, we consider this 25, okay, and water 167 minus 42 is equal to 125, right? And cement is equal to 126 upon 0.45 is equal to 280 kilogram. So finally the water required is 167, okay, if we are using super plasticizer. Now water is equal to point. If we are using super plasticizer, we can reduce the water content. That will be beneficial for better strength and better performance. So W is equal to 0.75 into 167, that is equal to 126 kilogram per meter cube is cement content. Right. So now 126 is water content we required. C cement is equal to 126 upon 0.45, that is equal to whatever the answer is. Right. Now step 4, table 4, and we get the estimate of coarse aggregate, volume upon volume of total aggregate. Right. So we have maximum size of aggregate 20 mm, zone 3 sand, right, that is 4, permeability 10% should be reduced. So water cement ratio we have is 0.45 and water content is 167. So maximum cement content is 300. Right, so that is equal to 372. Means if you consider fine aggregate content, then 167 plus 372 upon specific gravity of cement, that is 3.15, plus 1 upon 1 minus 0.64. Right, into fine aggregate upon specific gravity of fine aggregate into 1 upon 1000 is equal to fine aggregate content we get 695 kilogram per meter cube. Now coarse aggregate. Coarse aggregate 1 is equal to 167 plus 372 upon 3.15 plus 1 upon 0.64. Right, we need how much percentage of coarse aggregate, that is 0.64 into coarse aggregate upon 2.6 into 1 upon 1000 is equal to 1190 kilogram per meter cube coarse aggregate is required. Right. So now, if you consider without super plasticizer and fly ash, water content is 167 kilogram per meter cube. Cement we have 372. So fine aggregate is 695 and coarse aggregate 1190. Total is 2425 kilogram per meter cube. But if we consider super plasticizer, so W is equal to 126. We checked earlier. 126, I think. With super plasticizer, I think this one. Okay, if you are using super plasticizer, then you have to reduce the water content, that is equal to 126. And if you are not reducing water content, then it will be 167. But if you are using super plasticizer, then water content is 126 and cement is now reduced to 280. So fine aggregate is equal to 126 plus 286 is cement content upon specific gravity of cement, that is 3.15. Okay, I think now it is visible. 3.15 plus fine aggregate upon 1 minus 0.64. Okay, that is, now the answer will be your fine aggregate content. Okay, and further if we consider for coarse aggregate, then 126 plus 280 upon 3.15 plus coarse aggregate upon 2.6 is the density of specific gravity of coarse aggregate into 0.64. Whatever the answer is, coarse aggregate content. If fly ash is 25%, then 0.25 is equal to F upon C plus F. then C dash is equal to 1.1 into 372 is equal to 400. So F upon 400 is equal to 0.25, right? So F is equal to 100, right? So your fly ash content will be 100 and C dash is equal to 300. So these are the contents. Now if we are using superplasticizer,